All right, Algebra 1A students. Welcome to part 2 of your video on lesson 6.3. We're going to continue our discussion of solving systems of equations using the elimination method. So we looked in our last video at what it looks like to eliminate a variable from a system of equations and when it's very easy to do that. In the last video we looked at adding two equations together. In this video we're going to do the same thing, but we're actually going to subtract the two equations, every piece of those two equations from each other, instead of adding them together. We're going to do it by subtraction, okay? And we need to do this in a little bit different circumstance, okay? In the last video we looked at examples where we would have had something like a negative 5x plus y equals 1, and then a 5x plus 2y equals 7. Right? So we had a negative 5 and we had a positive 5 on the x's. These were the same number but opposite signs, right? So that's when we added them together to get them to cancel out. We canceled them out by adding them together. Now, in this video, we're going to actually look at situations where we have a variable where the coefficients are exactly the same number and the same sign. So not just that they're both 5s, but that they're both positive 5s, or that they're both negative 5s, or something like that. Okay? Positive or negative, they're both exactly the same number. They're both positive, they're both negative, they're both 4s on one of our variables. Okay? An example of this would be here. In this case, the variable that has the same number on the variable with the coefficient that's the same in both equations is the y, because right here I have a 3, and right here I also have a 3. Okay, but the thing we have to notice is that both of these are plus signs. Plus sign right here, plus sign right here. Okay, both of these are plus signs, so they are exactly the same number. They're both positive 3. Same sign, same number, they're exactly the same. In this situation, what we do is we subtract every piece of these two equations. Okay, and what that looks like is we take the number in front of the x's and we subtract them, then the number in front of the y's, and then the numbers here at the end. Now the order does matter in this case, so we have to be careful to do negative 4, take away 2 more. Negative 4 take away 2 more gets us down to negative 6x. 3y take away 3y actually cancels out. Those are not there anymore. And the other side of my equal sign is 12 take away 30, which is negative 18. Okay, so now that I have this equation, it no longer involves a y. I can simply divide away the number that's attached to my x. Divide by negative 6, divide by negative 6. That goes away, and I get x is equal to negative 18 divided by negative 6 makes a positive 3. And now I need to plug this back into one of my top two equations. I'm going to plug it right back into, over here, and see what we get. I believe that bottom equation then is going to say 2 times 3 plus 3y equals 30. Right? 2 times 3 is 6. 6 plus 3y equals 30. And then 3y equals 24, as I take 6 away. And what I end up with is y equals 24 divided by 3. And I get y equals 8. So my final answer as a coordinate point here is 3, 8. X number first, y number second. That's my final answer. Now the only thing that was different in this video from the last one was the fact that I started with a subtraction right there instead of an addition, because the 3y's had exactly the same sign, both were pluses. Okay. So here's one for you guys to try. The thing I want you to be careful of is subtracting negative values. Subtracting a negative is like adding a positive, remember that. But notice, please, that here we have 4x and 4x, which are exactly the same. So we'll start this by eliminating the x's with subtraction. So pause the video for a second, take a look at this problem, then come on back and I'll show you what we should get. Okay, the 4x's disappear. 1y, take away negative 3. Taking away negative 3 is like adding 3, so we get 4y, and it's equal to 13 take away negative 7. Take away negative 7 is like adding, so that makes 20. 4y equals 20, which leads us pretty quickly to the fact that y is equal to 5. Right? And if y is equal to 5, I want to figure out what x is equal to, so I will take the 5, put it back in there, and what I end up with is 4x plus 5 equals 13. And then I just need to solve this for x. So I will subtract 5 on both sides. It'll say 4x equals 8. If 4x equals 8, then that means x equals 2. And again, when I write my answer, my x number needs to come first, 2, 5. Okay, this is my final answer right here. 2, 5 is the solution to that system of equations. If you have questions at all about solving systems of equations by subtracting two equations to eliminate a variable, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.